Hello, we are continuing right along in our lessons in Unit 3. Remember, this unit is all about solving quadratic equations. In this unit, we have some nuanced things that we have to learn, like last lesson, simplifying radicals. Or in this lesson, we're going to learn, this is lesson 4, we're going to learn about what mathematicians call imaginary numbers. Okay, so first of all, let's define what is called imaginary numbers. The first thing we need to clarify is imaginary doesn't mean that they're not real, that we don't have a thing. It just means that mathematicians didn't know what they were in the beginning, so they called them imaginary. Should have been a different word, a better word. But for now, we're just going to call them imaginary numbers. And so where did this come from? Equations such as this. When I have x squared plus 1 equals 0. When I go to solve this, I'll get a negative 1. X squared equals a negative 1. And you can't take the square root of a negative number. There's no real solution. So what happened was mathematicians defined what the imaginary number was to represent in their solutions. So this is what we came up with. So the imaginary unit we call I. It's defined as I is when you have the square root of a negative 1. We're going to convert any square root of a negative 1 to the letter I. This is useful when we're working with square roots of negative numbers. So that'll help us solve when we can convert it to an I. The next sentence says a pure imaginary number. So we're talking about a different definition. A pure imaginary number is written in the form of BI, where B is a real number and I is the imaginary part. Okay, so now that we understand that I is just a representation of the square root of negative 1, we're now going to work through the steps of how we simplify negative square roots. So there are some steps. The steps go like this. Hold on just a second. Sorry, the steps go like this. First, we're going to rewrite any negative number as negative 1 times that number. Then we will break down A if it's not a perfect square. Remember, simplifying those radicals. And then finally, we're going to simplify the radical and recall that radical negative 1 means I. Okay, so very first thing, we're going to rewrite. So let's rewrite this equation. So instead of as radical negative 9, we're going to rewrite it as radical negative 1 times 9, right? Because negative 1 times 9 is negative 9. Learning those radical steps, I'll normally break it apart ahead of time. If it's all under the same radical, means the same thing as a radical times a radical. So now, we're going to break down our perfect square radical. So we have that negative 1. 9 is a perfect square, so 9 is really 3. And then we have radical negative 1. Well, radical negative 1 is I, so the answer to this is 3I. They wrote it up here as negative 1 times the number. I'm going to switch those places because I like the negative 1 to be second because that becomes I, and we write I as the second value. So let's go ahead and write this. This is 196 times negative 1, radical 196 times radical negative 1. 196 is a perfect number. It's 14 times 14. So this is 14 radical negative 1, or 14I. This will be radical 5 times radical negative 1. I'm starting to skip some steps. Notice I'm not writing it all under the same radical. I'm going to go ahead and move on to this step. So I'm skipping this portion where I write it all under the same radical. means the same thing. Radical 5 can't be simplified. If it can't be simplified, the radical goes first. So radical -1 is I, and then radical 5. If you have a radical left over in your answer, it goes last. So numbers, letters, then radicals. Okay, so first things first. Don't know which one's going to happen, so -1 times radical 80. We know that at the end, that radical -1 is going to become I. So it's okay to turn into I in the very beginning. Now we're going to think of factors of 80. 80, the biggest perfect square that goes into 80. It is divisible by 4, but it'll have more perfect squares. Radical 16 times radical 5. 16 times 5 is 80. And radical 16 simplifies to be 4. So if we're writing it in the proper order, 4i radical 5. All right, let's repeat this process. Let's see if we can make sense of it. So we're going to have a -1 and a radical 32. Well, 32 are the two factors. 16 times 2. So radical -1 is I, radical 16 is 4, radical 2 stays radical 2. Write it in order, 4i radical 2. All right, our next one. Write it as radical 192 times radical -1. 192 we can split into its factors of radical 64 times 3, and that'll be an I. 64 simplifies to be 8. We'll write the I next to the 8, and then radical 3 will stay. Okay, I'm going to pause there. That is simplifying those radicals when there is a negative in there. Now we're going to put it into equations. We're going to say, okay, let's solve some equations, and we're going to see some negative radicals. Okay, so if we're solving by square roots, remember, we don't want it to equal 0. We want to isolate the x squared. So we're going to move everything away from the x squared. Now, solving tells me I'm going to take the square root of both sides. So that's going to give me x equals plus or minus radical -81. Well, now we have to break this apart. I have plus or minus radical -1 times radical 81. X equals plus or minus I times 9, and now we just have to write it in the right way. X equals plus or minus 9i. So we have two answers, a positive 9i and a negative 9i. Okay, again, we have an x squared, so our goal is to move everything over, away from it, so I can take the square root of both sides. Okay, we have x squared equals -4. Take the square root of both sides. Square and square root cancel. I'm left with x equals radical, not a radical yet, plus or minus radical -1 times radical 4. Radical 4 is a 2, -1 is an I, plus or minus 2i. All right, continuing. Again, we're going to move this 15 away from it. 4x squared equals a -24. Divide both sides by 4. I get x squared equals a -6. Now take the square root of both sides. That's going to leave me with x equals plus or minus radical -1 times radical 6. We know radical -1 is going to be I. 6 is the factors 3 times 2, but neither of those are a perfect square, so that is my final answer. Okay, last one on this page. Move this guy over. I get x squared equals negative 12. Now I take the square root of both sides. Those cancel, so I get x equals plus or minus radical negative 1 times radical 12. 12 can be rewritten as its factors. Radical negative 1 is I. 12 is radical 4 times radical 3. X equals plus or minus. Radical 4 is 2, so we're going to write it as 2I radical 3. Stop that video. We'll start the next one on the next page.